So if you look at link syntax can be, as I was telling you, it can be written in two manners: query syntax, method syntax, or mixed syntax. This is a typical example of query syntax. This is an array. And if you look at, I have told you one particular thing, that any data source, whether it is XML, whether it is database, whether it is ADO.NET objects, if there's if the data source has enumerable interface, I can use link out here. So this is basically, we can say this is nothing but a memory object.
Right.
All right, this is a memory object, right? This is not a data source or ADO.NET object. This is a memory object, simple memory objects. This is another as database object. Now I am using a query language out here. This is called the LINQ structure, language query syntax, language integrated query syntax. Okay. Return type of this is a enumerable interface. And that is the reason I can use the LINQ query syntax out here. Okay. Now here is the integer list which will throw out any numbers greater than 5, and that is where this is shown. So this is a LINQ query using the query syntax. In the same fashion, the same example can be shown with, with your method syntax. Now, if you understand it, there are three portions of a LINQ. One is initiation part, initialization part, condition part, and execution part. So query syntax will have all the three parts. Similarly, a method syntax will also have three parts. So method syntax becomes the most popular nowadays to write LINQ queries. It uses lambda expression to define the condition for the query. Okay. Method syntax is easy to write, simple queries to perform read-write operations on a particular data source. For a complex queries, method syntaxes are a little hard as compared to query. So if you have complex queries, don't use method syntax, use query syntax. In this, so method syntax would use lambda expressions also to define the conditions for the query. And so in this approach, the LINQ query is written by using multiple methods and combining them with a dot. So we'll have data source dot condition method, that is condition. Data source is initiation. Condition method, you have conditions. And third part is selection, execution rather, I would say, selection method. And this is where you will use the lambda expression, you'll see that. So the same example where we are trying to get numbers greater than 5, I'll show you with method syntax. And that's defined out in your 2 LINQ example. You can see this one. Shall make this as startup project. And open this up. So this is a data source again. You can see a list of integers. It's a memory object again, containing values from 1 to 10. These are the items in the list. Using the generic, the systems or collections are generic namespace. So this is a generic collection. This is now where the LINQ query is using method syntax. So this is the data source. Then this is the
I see.
Where method. Initiation, data source. Then this is your query method, which is defined out here as
Condition.
conditions. And then selection method. Selection method is toList.
And the condition method.
And in the where, you are using a lambda expression. So this is your lambda expression.
Got it.
I hope you know lambda expressions. Is an anonymous function which uses this particular symbol. And this is returning an object greater than 50. This is a returning object is nothing but anything which is returning greater than 5. That's the lambda expression. And then toList is the selection method. Because a toList is basically a method which will return to a list of integers, you can see. Hover your mouse to understand what is it returning. The selection method is returning list of integers. So that is kept to a variable var method syntax, and then use the for each loop to execute all the items of the list which has value greater than 5. So this will have values greater than 5. So 6, 7, 8, 9, 10 is the method syntax. The var keyword is used with the variable name as items. So items will actually have the items in this variable. And how many times the for each will run? 5
Um,
times.
yeah.
When you run it, you will get 6, 7, 8, 9, 10. All right. Again, you are getting the numbers in the same line. That's because you have used the console.write method, not the write line. Write line method will move the cursor to a new line.
Yeah.
All right. So very simple to understand. No rocket science out here. So the only thing is that you need to understand this is a method syntax.
Yeah.
Whereas this one is the query syntax.
Yeah.
Okay. The third part is your mixed syntax. Mixed syntax looks like this. It's a combination of query and method syntax. So you will have above part from object in data source, that's part of the query syntax, where condition select object dot method. This is the method syntax, and that is until here, from until select object is in parentheses, that is the query syntax. Okay. So example be first we need to filter the list where the value is higher than 5, and then we need to calculate the sum. All right. So we'll see an example out here of mixed syntax. That's defined out here. That's the example of mixed syntax. Same list of integers. So I want a link query using mixed syntax. This part is in parentheses is nothing but query syntax. So I'm getting all the values greater than 5 and then sum it up. This is method syntax portion. So from this list, from this object in the integer list, this is the data source. Okay, where object is greater than 5, that means these. Select the object, select those object. Okay, so I'm here, if you look at in a query syntax, we don't require to use a for each loop. If you look here also, in a query syntax here, this is where I have used a for each loop to get the query syntax. If I want all the items, then I needed basically to use this. For example, here, for example, I wanted each item in method syntax variable. So I would say that for each var item in the collection. And this returns an integer anyway. Um, and then I will not get a summation. What I need to do is that I have to add out here, and after that, this will be nothing but a query syntax right now. If I call this again, dot sum method. So a lot of methods you can see dot if you put to list, to array. These are methods, selection methods. Where method, aggregate, append. Like similarly, you have some.
Those are like the group by stuff, right?
Yeah.
Okay.
I can print out this. So I can get items as well as summation of the item. This is a typical example of LINQ query using mix syntax. On this. Okay, didn't I make this as a startup project? No. Not make this. So you're getting all the items and summation of the items is 40. You can see 6, 7, 8, 9, 10 summed up together is equal to 40. That's what it is saying.
Yeah.
That's precisely your mixed query. Now, lambda expression syntax, I've just given a LINQ lambda expression syntax out here. Most of you will know it. In LINQ, lambda expression is a function without a name. It's an anonymous function. It makes the syntax short and clear. Though lambda expression is not readable as a LINQ query, it is equally important as the LINQ query, and it converts into lambda internally. So where you are using the lambda expression out here, if you go to the earlier one,
Yeah.
This not here.
In the where condition, something like that.
This is used in the method syntax out here.
Right, right.
This is where the lambda expression is used. The condition is defined by the where method. So though the lambda expression is not readable as the LINQ query, it is equally important as the LINQ query and converts into lambda internally. Scope of lambda expression is limited when we use it in expression. Lambda expressions cannot be used afterwards. Okay, the syntax of defining a lambda expression is as method expression. Input parameter is equal to method expression. Okay, lambda expression is dynamic and decides the type of class at compile time. That we already know it. And it's all behavior of the lambda expression. In the above lambda expression on the left hand side, input parameter, we have a bracket which contains the input parameter. The name of the parameter can be anything. Ahead of this parameter is this symbol is an equal to symbol followed by a greater than sign, which is used to send or pass the parameter from left to right hand side. Obviously, this is the method expression. And on the right hand side, we perform the operation using the input parameter, which will pass from the left hand side parameter. The whole syntax forms a lambda expression. This is a typical write up on that. Already know it. So example of commonly used expression is x is equal to x plus 10. That means x is equal to x plus 10. So whatever is the value of x, that will be added with 10. So here the x is the input parameter followed by this particular symbol, lambda operator symbol. And next to the operator, there is the expression that adds numeric 10 to the input variable x. Output will increment the number 10 to x variables, which was the input parameter on the left hand side. So this is also an example to show you this. Just for your convenience, I put it, nothing else. Third, fourth, lambda expressions. So we have a list of strings out here. You can see list of strings. I'm using system.collection.generic namespace. And with the add method of the list, I'm adding these countries: India, US, Australia, Russia. Now we're going to use the lambda expression to show the list of countries. So if you look at, I'm using the select method. So here what I'm trying to do, I'm basically using the method syntax, not the query syntax out here. Selection method, x is equal to x. So here the select is the property that will be used to select from a list. X is the input parameter. Left hand side of the expression followed by our operator, lambda operator. Right hand side of the expression, we have the same input parameter. Denotes which we want to display the parameter without performing any operation on it. No operation. We are not specifying any condition on it also. So countries.select, it returns a I enumerable interface. You can see that. Okay. And then this will contain, so I enumerable is basically nothing but a interface. It starts with the I keyword, I letter actually. Okay, so you will enumerate over this particular interface result reference. So for var items in the result, this will print out the items. It will print out the same items out here, nothing else. I hope I made this as a startup project. This is just to show you a lambda expression, nothing else.
That lambda expression just selects everything, right?
Yeah.
Yeah.
I can use a where also out here. You can see that where method, and where I can say that x where x dot starts with, for example, A. Under these circumstances, it is basically going to give you Australia. It's going to iterate over Australia only.
Yeah.
Result will contain Australia. So run this, you will get Australia. So you can use lambda expression in select method as well as condition.
Right.
This is a typical example of method syntax. Okay. All right, let's go further. Now we'll see some aggregate functions of LINQ. Okay. These are built-in functions, so don't have to worry about remembering it. The slides are more than enough for you. I'll give you the slides and all the codes. So we have
Right.
something called the count function. The count function is used to count the number of elements in the list or collection. Okay, for example, you have a integer array which has 9 items. The count method or function is going to count the number of items. So let's see an example of this straightforward. It's very easy. So let's close all this. You got the count function directly.
Sorry.
Oh, before count, there's max pin, sum, then count comes. So that's what I was thinking. So I made the codes based on that numbering. And that's why you can see that fifth is showing me, I came to know because fifth is showing me lambda minimum function. You can see that.
Yeah, yeah.
So I got confused what's happening. All right. So min function is also straightforward. My minimum value from a collection or list. So we have to write a bit of code to get the minimum value from the list of available values. So you have an integer array and 1 until 9 and want to get the minimum value, that will be 1. The return to the minimum method will be integer again because number out here. So we will see an example how to use the minimum function. Let's go out. Integer array you can see and min function. So minimum value of the given array is this. Use the min function. So a dot min directly you can use, and it returns a integer of enumerable. You can see that.
Okay.
Okay, and then you can basically do a string interpolation, stating that you can use the $sign for string interpolation out here. I hope you know this.
String interpolation.
Yeah.
Like
You have to use a $sign.
Yeah.
You got to use everything inside the in double quotes, and you have to put the variables inside curly braces.
Yeah.
Along this way.
So
So that's going to print out the minimum number is 1. Let's run this. Yes, minimum var number is 1. You can see that. And if you put dot, you will see other methods also. And compared to further dot, the dot method compared to any other value, get the hash rate, convert it to a string. Minimum value is equals to, I can do that equals, it is equal to, equals basically is equals to 1. That has to take a string value. Equals is a method of the string class. Can't use it. You can convert it to a string, toString.
yeah.
Okay,
So-
that will be created. So toString method returns a string. This has to be a string.
So I have a question.
Yeah.
The min method can only be used for collections or that are integers, right? You can't like use a min on a string, on a list of strings.
No, min method precisely. You can have a string array. You can run that.
Oh, okay. Okay.
So you can basically have a string array like this. String A1. And then I can basically say that A1 dot and this returns, you can say a string array variable. So you can say string
I got it.
1.
Nice.
Okay, that's the minimum function, and then we have the max function. It's just the opposite of min. You can understand it. Give the max, we use the max function out here. That also can be done. 6th. Make this as a startup project, and then run this. So max function is used. You can see this, and this returns a integer enumerable.
I see.
LINQ will always use this interface. That's how LINQ is recognized.
Yeah.
And whichever objects or database or data has high enumerable interface implemented, you can use LINQ out there. Okay. And this you can run this. Maximum value is 9, you can say. And that's very straightforward. This is very, very easy. Sum function. The sum function is to calculate the sum of the items in the collection or list. We have to write a bit of code to get a summation. So sum function is something like this. Integer dot sum. So basically, whether it is an integer, it is an array, or is a collection or a list, it will add the items, nothing else. Okay. So I can go to make this a startup project. So create an array with initialization the values. So you can, instead of array, you can create a list of integers or a list of something, or a collection of something as you wish to. And then we'll just calculate, this will be printed out. Use the summation, the sum method to add the values or to add the values of the num array. Okay, use
Yep.
the num function. That's all. Return type of this will be a number. But if you try to implement the same thing, for strings, what will happen? Let's say I make this a string.
Will they concatenate? Wait, I think you have like two different types of quotations. One's like a two quotation, one is singular.
str.sum.
Is it because the type is
Now you can see
so it won't work.
does not contain definition for sum.
Right.
So it is used for numbers. You can see that. Just to make you understand. Sum AS cannot be possible. So I'm commenting it. I'm not removing that. Then you have count. Count is out here. To count the number of items, you have the count method. That's also straightforward. So where arrays, you can have a collection. It can be any kind of array, string array or whatever, object array also. Collection can be of list or anything else. And find the count of the number of items. Just to find the number of values in a num array, for example, this one, we'll apply the count function, num.count directly. Returns the integer value, count the integer of enumerable interface.
Got it.
That's straightforward. Again, the count number of items would be 10. You can see that. And then we have the aggregate function. All right, yeah. So the aggregate function is basically used to perform operation on each item of the list. Aggregate function performs the action on the first and second elements, and then carry forward the result. For the next operation, it will consider the previous result and the third element, and then the carry forwards, etc. Okay. So num.aggregate AB.
Oh wow.
It will do a carry forward. You can see that.
Okay.
So a aggregate A, B, these two are the functions parameter A plus B. So this will be added, and this value will be added with 3, and then 3 plus 3, 6, 6 plus 4, 10.
Okay. I got it.
Okay, but if you do a console.writeLine, output will be 10. So that is the write up defined out here. So in the above syntax, we have two elements, 1 and 2. To perform the addition and make it 3, then it takes the previous result 3 and next element 3. 3 plus is 3 is 6, and perform the addition to make it 6. And 6 is added with 4 again to make the result as 10. So let's say an aggregate function. That's how it works, and it is very, very, if you want to do an aggregate function or this kind of scenario with simple code where you don't use LINQ, number of codes will be more. That's one of the behaviors of LINQ also, that it reduces the number of codes.
Right.
That's what it's about. The integer of numbers, you can see product of the elements I want to get. So aggregate, then A and B. So you can see it is a aggregate function. If you look at this portion, is a lambda expression. So A into me. And then this lambda expression is inside the aggregate function. Okay, so aggregate function has this parameter which is taking a lambda expression. So product is double average. So output will be what? 1 into 2 is 3, 3 into 3 is 9, 9 into 4 is 36, 36 into 5, whatever it is, that into 6, something of that sort.
Yeah.
That will give you output of 362,880. And the breakup I have given out here. 1 into 3, 3 multiplied by 3, 6 multiplied by 4, 4 multiplied by 5, not 4. 3 into 3 is 6, 6 into 4 is 24, 24 into 5 is 120, 120 multiplied by 6 is whatever is the result is multiplied by 7, 8, 9. That's
Yeah.
what I will do. So let's run that first, and then I'll run the rest. This one later on. So we're getting the product 362,880. That's the result of the aggregate function doing for multiplication out here, product of the elements. And then I've used the aggregate function on a character set. String array rather, I would say. A string array containing A, B, C, D. This is where you can use aggregate, and just use like this. This is the lambda operation performed on the aggregate function. A concatenate comma concatenate B. So the concatenate strings will be the concat method being called here. Output will be A comma B comma C comma D. Okay. So let's run this. A comma B comma C comma D.
I see.
All right. So that's some of the aggregate functions that we have in LINQ. And then we see some sorting operators.
Oh, wow.
So the sorting operators will be order by descending, then by descending, and reverse. By default, order by will be in ascending order, then by in ascending order. So sorting operators in LINQ are used to change the order or sequence of the data, either ascending or descending, based on one or more attributes. So you can see this is a simple figure to show you the sorting operators. Nothing else. And we have the reverse also. So all these sorting operators are used to sort the data. But the reverse operator reverses the items in the collection. The rest operators are used to order the data, just like we use order by clause in SQL. Okay. These sorting operators are similar to SQL, but the only difference is that we are using the operators in LINQ right now. So we'll stay each by of them. So if you look at, this is the order by, what it does. Description is that operator will sort the values in ascending order. Query syntax is order by. Order by descending means the operator will sort the values in descending order. Order by descending. Then by, the operator is used to perform the secondary sorting in ascending order. Order by and then use then by. Then by descending, this operator is used to perform sorting descending order. First you have to use order by, then by order by descending, and then do it. Reverse, the operator is used to reverse the order of the elements. Okay, query syntax not applicable. So let's see this order by operator. The order by operator used to sort the list of collection values in ascending order.
Mhm.
In LINQ, we have to use the order by, the operator by default. It will sort the list of values in ascending order. We don't need to add any ascending condition in the query statement. So example, order by, and then the lambda expression, order by name. Okay, we'll see an example of it. That is where we'll understand it. Ninth, right? 10th. Tenth is here, sorry. So if you look at, I've created a class called a student, and I have three properties with the get and set method. Properties are name, string format, gender, string format, and the subjects are list of strings. Okay. Now, where I'm setting the values in the class called as program in the main method, the list of students. So this get and set property is defined, is set out here. List of students. I'm creating an object of the students class and defining the name, gender, and subjects. This is a name, gender, subjects. Subjects will be in list of strings. Get and set. You can see that. Okay. List of strings. Mathematics, physics. Okay.
Yeah.
So this is a list of students out here. Okay. And their genders are defined. So I'm setting the values for these properties out here in the program class. So list of students, and students is a class. It contains the name, gender, and the subject, which is a list of subjects right now, because subject is defined as a list of strings. That's why it is defined like this. Okay, now in this above example, we declared a variable student name of type var. And used order by clause. Here you can see. So object students order by, where you can order by name. So order by name. So it can be alphabetical order, nothing else. Okay. And 1, 2, 3, 4, 5 students, right? So this will have 5 students in your ordering, you're getting the value out here. There you have set the value, you get the value by the name. So this will have 5 names. So you are iterating over the 5 names. Student name, var student and student name, and printing out the student's name. This will be ordering by student's name. That is what it is doing, nothing else.
Yeah.
You can see alphabetical order. Okay, so I can basically order by gender also if you wish to. So the only thing that you have to do is female, male, male, male.
Yeah.
That's the order by, and this is in ascending order. You can see by default it is in ascending order, and that is why when I run this, you will get an ascending order, down to up.
Yep.
M P R S S S A and this S U. And similarly, we have something called as order by Where's that? Order by descending. Used to sort the list values in descending order. Syntax is defined by this. Example is what? The same thing with an example. LINQ order by descending. Same class student. I have here I have defined four properties, get and set method, role ID, name, gender, subjects. Okay, and this is where I'm creating a list of students and defining the object of the students class, where I define the role, name, gender, subjects. Subjects will be in a list of strings. You can see this out here. So this is where I'm setting the values, and then from this object students, I'm